So yeah, we're looking at the two types of loops. So the for loop that we studied before Thanksgiving for x in range 0, 1, 10. Starts at 0, stops when it gets to 10, counts by ones. So remember, use this loop when you know the exact number of times your code should run. Let's compare that to a while loop, which we're studying this week. This command waits for an event to happen, and it tells Python to repeat the action while a certain condition is true. So you use this loop when you don't know the exact number of times you need your code to run, but you know when it needs to stop running. All right. So here's an example. We set x equal to 0. And then while x is less than 10, we tell it to add 1 to x. So it'll go back and it'll do that. It'll keep doing that loop until x equals 10, then it'll stop doing that. Now, that's a very simple thing. We didn't really have it programmed much other than just add 1 to x. But that's how a while loop does the same thing this one does. So there's the command in the for loops. We tell it to run 10 times. Here's where in a while, where we tell it to change the value of x and then check to see if x is still in our parameters. So here's a nice Venn diagram showing how they're different and how they're similar. And so for loops repeat for a set of values. Over here, while loops repeat while a Boolean condition is true. And Boolean conditions like greater than, less than, greater than, equal to, or equal to by itself, or less than or greater, or less than or equal to. That's a Boolean condition. The loop variable is given a start value. We tell it to start at 0 or 1 or whatever. And the loop variable is assigned a value before the loop on while loops. You know, it said that x equals 0 or x equals 1. You know, you said that before you did the while. This is best used when you know the exact number of repetitions needed. This is best used when you do not know the exact number of repetitions needed. You just know where it's supposed to stop. Here's where they're the same. They both repeat a block of code, whatever you have in the loop, and it will stop once the condition is false. All right? If x is less than 10. Oh, that's false now because x is 10 or x is 12. And this is when it hits 10, it's no longer smaller than 10, so it'll stop. All right, let's look over here. Worth your while loops. Yeah. So we've all seen this on Netflix. Are you still watching? It's been 16 hours. You're covered in chips. Really think about it. Now, it'd be funny if Netflix actually had some funny messages. They're usually just, are you still watching? It's like, quit shaming me. I'm trying to binge the show. Imagine your friends have been binge watching your favorite new show. There are 7 seasons, and you're going to watch it till you see the finale. It's going to be a long but epic weekend. Something keeps happening. Every time an episode ends, a pop-up appears. That's whether you want to keep watching. Can I stay awake for another one? This is when a while loop would be useful. Ask yourself, while I stay awake, keep playing the show. Or you could say, while there's still episodes left, keep playing the show. That's the same type of thing. So we use while loops to repeat actions when we cannot find the number of necessary iterations easily, or there's no way of knowing the specific number, how many times the loop needs to run. So here's some important syntax points. The statement begins with the word while. The test condition goes inside the parentheses. What are you checking? The statement ends with a colon. Notice there's a colon there at the end after the parentheses. And then the code in the body of the loop gets indented. You have to indent what is part of the while. Right? We said while, and then we indent what is in the while. So here's an example. Answer equals y. So the answer is yes. Notice for an equals here in the while loop, you use 2 equal signs back to back. So it says Trixie.circle 25. Trixie.left 25. Remember, this is circling that distance. This code is with the while loop, then to show part of the while loop. And we'll learn more on the Trixie stuff. Answer equals input. Would you like to draw another? See, that's doing a circle. And so yes or no. So that's having someone input the answer. If someone says yes, while the answer equals yes, as long as they keep saying yes, it'll draw another circle, draw another circle, draw another circle, draw another circle, until finally they hit no, and it'll stop. So that's why a while loop works better than a for loop here. A for loop's going to draw an exact number of circles, whatever you set the parameters at. The while is checking every time. Oh, is it yes or no? Is it yes or no? Is it yes or no? So while loop needs 2 things: what action to do, which is the drawing the circle in this case, and the conditions for doing it. This time they're going to keep drawing the circle while the answer is yes. So there's a few instances that work like that. While it's raining outside, use an umbrella. While there's still ripe fruit on the tree, pick it. While there's not, you don't. The logic both ways. While ride's in progress, keep your hands, arms, legs, and feet inside, right, for your safety. While I'm following you on Instagram, I can see your photos, but if I unfollow you, not so much. Hashtag that shows how while loops work. They're trying to get all clever with the hashtag. So here's the Boolean conditions. Here's what you need to know for the while loops, because you got to use Boolean logic. So if you want to use less or equal to, in algebra, we write it like that. We do the less than with a little bar underneath it to show less or equal. In programming, you put them one right after the other. You do less than equal. That is the same as the algebra right there. Less than is the same. Remember, the equal, instead of using one, in a while loop, for Boolean, in a while loop, you got to put two equal signs. So you'll have some syntax errors if you don't have these correct there. If you want not equal to, you put an exclamation point in front of the equal. Exclamation equal. So not equal. Greater than is the same, and then greater than or equal works just like the less than or equal. You put the equal sign after it. All right, so as long as it's true, as long as it's less than, it'll keep repeating until it comes where it's not less than. If you do less than or equal, it'll keep repeating when it's equal. But once it gets larger, it'll stop repeating. So here's one of their guided activities. All right, so let's look at this activity. Read the code, try to predict the output. Hashtag the while loop, define main, x equals 0. While x is less than 5, print x. X equals x plus 1. Main. What do you expect the output to look like? Somebody take a guess on that. I'm going to put the chat on now. It's a simple while loop. While x is less than 5, what do you expect the output to look like? Y'all aren't still in a turkey coma, are you? Let's see. Well, x equals 0 first. They define x. And then say while, there's our Boolean logic, while x is less than 5. And number 1 through 5, okay, there's a guess. Print x and then add 1 to x. And that's the end of the indentation. So it goes back to the while and checks again. That's a good guess, Nathan, but you're off just a little bit. It's going to start with 0. It's going to check, is 0 less than 5? Yes, it is. So I'm going to print 0, and then I'm going to add 1 to it. And then I'm going to do 2, and then I'm going to do 3, and 4, and 5. And then I'm going to add 1, make it 5. I'm going to come back up here and say, is 5 less than 5? No, it's not. And it's going to exit out of the wall. So let's look at this. 0, 1, 2, 3, 4. Starts at the 0, prints that, then adds 1. And when it gets to 5, it says, oh, 5 is not less than 5. So it won't do anything in the loop. It'll exit out of the loop and go to the end of the program. 0, 1, 2, 3, 4. Okay, let's look what it wants to do next. Read the code, try to predict the output. Modify the range of the while loop so the counts from 1 to 10. So they want the count to be from 1 to 10 instead of 0 to 5. So let's change this to 1 because that's what we want to start at. What do we need here? Well, x is less than 5. And we want it to count 1 to 10 on our output. Change the 5 to 10, Nathan says. Joel says make it an 11. Let's do the 10 first. On the program. 1, 2, 3, 5, 6, 7, 8. Oh, it stopped at 9. Because when it added us to 10, 10 is not less than 10. So it doesn't print 10 for us. So we got two ways of doing it. We can make this 11, run the program, and now we get the 10 down there. Or if we want to use Boolean logic differently, we can do less than or equal to 10. There you go. Daniel had that. You can make it x is less than or equal to 10. And then when we run it, we still get the 10. So either way, you can say less than 11 or less than or equal to 10. And we'll get that. Good job. Over here, they were just doing the x is less than 11, but I like the other option. It's easier to think about equal to 10 that we include that. Now they want us to look at this and try to do it. So import turtle. See that? So they're going to do some drawing. Let's look up here. Define main. Rosemary equals turtle.turtle. So that's what they're calling their variable from turtle. Speed equals 10. They're going to make it purple. Pin up, set position, pin down. Okay, that's interesting. We haven't used pin up and pin down here. Number of circles equals 10. X equals 0. So while X is less than the number of circles, so while X is 0 and it starts at 10 up here, so do a circle and then left 360 degrees, the number of circles divided by 10. So do 36 the first time. And then add 1 to X and it'll go through it again. So it'll keep doing that until X gets to 10. Let's run it and look and see what happens. Look at there. So this is going to keep doing that. That's how we make these really cool patterns in there with a while loop. So it's doing the circle and then it's going left. Excuse me. It's rotating left 360 by number of circles. So 36 degrees. So every time it's moving 36 degrees to the left of where it made the first circle. So 36 times 10 is 360. That's why it makes a full circle by the time it makes all of them. So it makes a circle with a 40, make the circle, and makes 10 of them, a while loop. So it sets all this conditions for the color of it. Okay, let's remember, you can always change things. We can make it a red circles. Nice. The while loop can be used to repeat while counting. So the number of circles determines how many times the loop will repeat. Of course, X is used as the counter. And it starts at 0 and it's incremented within the loop. Within the loop, we're changing X. You know, if we leave this line out, it's going to have a problem because X will always stay 0 and it'll be stuck in this while loop. It'll never get out of the loop because there's no end. X will never be equal to or greater than the number of circles. So you got to make sure whatever you're checking that somehow it's changing in your while loop or you can get stuck in there. All right, let's look at this. So let's just change the X's. So if we make the number of circles 5, we do it this time. We're not going to get all the way around. Oh, it makes it bigger this way. Okay, as we're dividing by 5. So we're moving it 72 degrees each time if we change the number of circles to 5. Oh, all right. Here's another one to predict the output. All right, so define main. We have one while statement. We start with the total at 0, and then we say, okay, as long as the total is less than 20, number integer. So num is our variable, and we have to enter it, and it's asking for input. Please enter a number, and it's making it an integer, and it's going to print the number, and then it's going to add that number to the total, and it's going to keep doing that until the total is 20 or larger. Because it says as long as the total is less than 20, go back and ask for another number. And then it'll print the total because each time it's adding the number to the total and it'll print the total at the end. So let's run this. It says, please enter a number. We'll enter 4. Oh, now it says, please enter a number. Let's enter 6. Let's enter 8. Let's enter 21. The total is 39. They added it all up once it got larger than 20. But as long as the total, 4, 6, that's 10, 18. See, at this point, our total is still less than 20, so it's still asking for more numbers. Right? And then it tells us our total once our total hits 20 or larger. All right, let's look at the next one. Read the code, try to predict the output. Print, let's find the total. Total equals 0, answer equals yes. As long as the answer is still yes, then we're going to say, please enter a number. We're going to print that number and add it to the total. And then ask, would you like to add another number? And then at the very end, when we finally say no, don't add any more numbers, it'll tell us the total of our numbers. So it works similar to the last one, but this time it should say enter a number. It should print it each time. Yes, I want to do another number. I'm going to do 2. Yes, I'm going to do another number. I'm going to do 88. See, this time, the only thing that's going to stop it is when I say no. There's not a total number it's going to get to. Yes. 1. No, I don't want to enter another number. So now, let's find the total. It prints each individual number, 11, 2, 88, and 1, and then the total of it. When I finally told it, I don't want to add any numbers. So it's kind of like making your own little calculator that can add numbers for you, right? Just writing a program to add numbers. It shows you all the numbers and it shows your total. So you could do that with any kind of things. You could have calculate averages. You can multiply numbers. You know, you can write a little program to make your own little calculator right here. All right, let's look at the next condition. Import turtle, doing more drawing. Turtle. Speed of 10. All right, so answer yes. And while the answer is yes, how many circles should be drawn? So num circles is our variable. They're making an integer, asking for input. How many circles should be drawn? The diameter. What's the diameter for the circles? It asks that also. Diameter is a variable. Trixie.color. What color is the turtle? This time we get to input that. So each time. So it sets x equal to 0. And while x is less than the number of circles, which is what we asked as input, that's a variable, then Trixie.left 360 divided by number of circles. Add 1 to x, because at some point we have to get out of this loop. And then would you like to draw another? All right, so if we'd like to draw another, then it'll go back up to this while loop. See, there's a while loop inside of a while loop. Do you want to draw another? Yes, and we'll do that. So let's run this. All right, how many circles should we draw? Let's say 20. Let's have a bunch of circles. What's the diameter for the circles? Let's say 10. And what color is the turtle? Blue. Look at that. Pretty small. Would you like to draw another? Yes, I would. How many circles should we draw? 4. Diameter is 50. We're going to make these bigger circles. What color is this one? It's going to be green. See, 4 circles. It's green. Would you like to draw another? Yes, let's do one more. How many circles should be drawn? Let's make it an odd number and see what it looks like. Let's do 13. Diameter for the circle will be 40. And this will be a red turtle. Yeah, 13 works real nicely. No, we'll say no, we're going to draw another one. So it has 2 while loops, one inside the other. So starts out asking us how many circles, the diameter, and the color, and then draws it all based on those variables. And then if we want to draw another one, it goes back up to this loop. As long as the answer is yes, then we input the stuff again. Now how many circles? Now what's the diameter? Now what's the color? And another while loop that actually draws it down here. So you can put loops inside loops, but just pay attention because it's easy to get lost and forget and get stuck in a loop if you don't give it an exit, a way to exit. You got to have a way to exit. This one's got x is less than num circles, and it's adding 1 to x every time. So eventually x will be larger than the number of circles. This one, checking to see if the answer is yes. And in that loop, it asks again, would you like to draw another? So at some point, that will be a no, and it'll get out of that loop. You got to make sure you provide an exit for your loops. Here's the last one they have. All right, try to predict the output again. All right, import turtle. Define main. Turtle. Speed of 10. The shape of the turtle. Options: turtle, arrow, circle, square, triangle, classic. Pin up, set position at 0, 30. Now it sets the answer at Y, and it says while the answer is Y, size is 1, input a color, input a shape. So that'll be interesting. We can try different shapes. For I, so we put a for loop in here. For I in range 15. Joe.stamp size equals size plus 2. Forward, whatever the number of the size is, and then turn left 30. Do you want to continue? So let's play with this and see what it does, because this has some new commands. All right, so it made the turtle graphics. Look, it's got a little turtle there for us. Enter a color. Let's see. Let's say pink. I haven't tried to see what pink looks like. Enter a shape. Let's do a arrow. How about that? Yeah, okay, so it makes these arrows and it's circling around. Each time the size is +2, so that's why it's spiraling out and getting bigger. It's getting bigger as it goes around. Do you want to continue? Yes. Enter a color. Let's see, black. Hair shape. Let's do classic. I don't know what classic looks like. Oh, classic is kind of like the arrow, but it has the little indented back. So yeah, you just get here and play with these things and see what it looks like. Let's do a square. That makes squares going around. Notice each one starts where the last one stopped. This is where the pink one stops, so the black one starts there. Black one stops up here, so that's where the blue one starts. Yeah, each one's starting where the last one stops. No, I don't want to continue, and that's where we're in there, out of it right there. So it's possible to write infinite loops, right? That's where your program gets stuck. For example, x equals 2, print x is less than or equal to 2, print it never ends. There's no way we ever changed x. If that's all you have is those conditions right there, it'll keep printing. It never ends. Actually, I think it won't even run. Let's copy that up here and put it in here. Let's replace all of this. That x equals 2, while print, it never ends. Oh, name x is not defined on line 6. Well, let me change it. Let's see. Oh, because I got to take that back. It was indented. Now, if I run the program, bad input on line 4. See what I need to do to change that. Oh, I got out of it. Gosh, went backwards somehow. Boolean conditions. Okay, let's go back to this. Ah, it's not working. All right, never mind. All right. Page 5 is just read the lesson, practice, and complete the quiz. This is just a multiple choice. We got 5 questions, but we'll be writing a program with the while loops soon. So make sure you understand them, go through all that stuff, and make sure you understand the difference between for and while. And those 5 questions kind of talks about the differences between them too. So you gotta know what you're talking about there. So, all right, that's it this week. We're just doing while loops. We did for loops before the break. So hopefully this will get you thinking about for loops again, so you don't lose that. Because like I say, we'll be writing programs. We just got a few weeks left before the semester ends. We're getting there, getting close. So you guys have a great day. We will see you Wednesday or next week. I need to check my calendar to see if it's right. I don't even know what this week is, but I will check and get that updated. The calendar says this week is I don't know. Oh, B-Day. B-Day. It's a B-Day. I'm changing it. All right. See you guys next time.